Excellent. Well, hello. My name is Nathan Stolzer. I'm the CEO and founder of Lonestar Data Technologies, and I'm going to be going over how we're using distributed ledger technology to provide security solutions for the Industry 4.0. Starting off, I would want to go over some key value points pointed out by the World Economic Forum and some of the main capabilities we take advantage of with distributed ledger technology. The first one being automation, which through network consensus and smart contracts, we're able to execute business policies into code. The security, the ability to encrypt and segregate data at the element level. Evidence tampering, with cryptographic and mathematical principles, we can validate the state of data to see if it had been tampered with or not. And distribution, where nodes share records, eliminating single points of failure. A little history in the state of Industry 4.0 and the history of automation. Beginning in the late 18th century, we saw advancements through mechanization, which is characterized by the steam engine and early adoption of factory systems. By the early 20th century, we saw machines transition to being powered by electricity and new methods such as Henry Ford's assembly line, enabling mass production. By the mid-century, computerization and robotics took place on the factory floor to help humans with their processes and their tasks. We're now transferring to a time where humans are actually phasing out of the production process in place of advanced technologies powered by artificial intelligence and big data and all connectivity. With this move to automation, there are some inherent security risks. Machine learning algorithms require large data sets that are consumable in order to train models. To gather this data to train the models, connected devices are being implemented on site to produce this information. These connected devices create a large surface area for attack. Even this morning, just running a basic security script showdown, I was able to identify 120,000 connected industrial control systems. And that's just industrial control systems that are literally say industrial control. So you could imagine the devices that don't say ICS to be near the millions. And this traditional operational technology was always designed to be a closed system, isolated from the outside world when it was implemented. Still operating on legacy communication protocols such as Modbus, which lack basic security features such as authentication, confidentiality, and replay protection. So anyone with communication to these devices can potentially control them. We've built a data-centric platform to enable trusted data streams for automation devices. By defining access control policies on the network level through smart contracts, employing cryptography principles to verify only authorized devices can have access to communication channels, and validating critical state variables such as flow rate, speed, or temperature through smart contracts that can validate themselves historically onto the ledger, as well as creating an immutable event log maintained by distributed consensus. In 2007, researchers from the Idaho National Laboratory wanted to conduct a security test to see vulnerabilities in the electrical grid. Solely through internet connections, they were able to alter the state variables of relay timing in a diesel generator. This got the diesel generator out of synchronization, and it actually tore itself apart. So imagine driving down the highway and then you just flip your transmission into reverse. What that would do to your transmission. You don't want to do that. So here's the actual the Aurora generator test. Ooh. To some people, this is terrifying. Oh, it's not playing on the screen. Well, anyways, it explodes. Well, if you watch it explode, you would realize there could be horrifying potentials, such as if one generator goes down, it could result into a cascading failure, where other generators in the grid, to compensate the loss of the initial generator, have to compensate and fail in a positive feedback loop, overall crashing the entire system. That's the number one cause of rolling blackouts. These generators are extremely expensive. 2.5 megawatt generators, such as the one pictured in the Aurora example, they range anywhere from $500,000 to $2 million per piece. And if one breaks, the uptime to replace it is extremely long, up to a year, because most of these generators and transformers are made custom spec. In the worst case scenario that could ever happen is a death or severe injury of a workplace operator. In 2015, these exploitations were actually seen in a real-world environment when malicious actors from Russia took control of Modbus protocols in a Ukrainian power grid. They were able to alter the same state variables that seen in the Aurora generator and take 30 generators down. While they were, as they were attacking, they used kill disk wiper malware to delete centralized logs that were critical to incident response. Counter incident response is pretty much the standard, the number one play in a hacker's playbook, to delete the record of them being there. So once incident's response actually got there, they had no idea what they were doing. So it's easy to see the value of immutability when it comes to something critical like event logs. The aftermath of the attack, 30 substations were down for 12 hours. 250,000 residents went without power. Damaged operational equipment in these substations, and overall just terrible PR for Ukraine and the state of cybersecurity. How could distributed ledger technology have prevented this? Well, proper encryption techniques would have made it difficult for hackers to identify communication channels, defining access permissions on Modbus to define just control, validating state variables to detect anomalies, and then last case, retaining immutable event logs. So if a scenario did occur, you could retain what Modbus access control was compromised and other details critical in recovery. So 2020 is going to be a big year for Lonestar. We're taking advantage of our geography of being in Texas and working in penetrating the oil and gas industry. We built a proof of concept for a Mexican upstream oil production company, where we'll be verifying access control from their Modbus terminals and other communication protocols, monitoring critical state variables that come off their on-site programmable logic controllers, and aggregating that data onto a distributed ledger. Here's an example of an example transaction from that proof of concept. The transaction hash representing the individual transaction, the contract representing the company, the IP that the device was located on from the remote terminal unit, the user in control of that Modbus policy, in this case Jose Ramon, the device ID, and then the state variable, in this case a temperature value. We'll also be serving as a key component in a large predictive maintenance project for a major oil company in the UK, where we'll be securing and validating the communication channels from the industrial devices to the cloud, where we'll be ledgering this data to be fed into predictive maintenance models. This year we had a lot of great things happen for us, like getting into the Capital Factory Accelerator and forming a lot of partnerships with IoT manufacturers in the oil and gas industry, automation service providers who are implementing connected solutions in a variety of industries, and artificial intelligence companies looking to gather data in sensitive areas. We recently sat down with the former CEO of DJI to talk about potential applications of our solution in the commercial drone industry, in which he forecasted that validating communication channels will be one of the biggest issues drones face as they hit the market and become fully autonomous. We're also looking to expand into smart cities, and we're looking at asset management solutions, as well as just expanding our overall Industry 4.0 service offering. When we designed our solution, we always intended it to be consensus modular, so we can operate on Ethereum and Neo, but we use Hedera Hashgraph for a variety of reasons. Their gossip protocol allows for high throughput and high transaction speeds. They are asynchronous Byzantine fault tolerant, which is the highest standard of distribution or security in distributed systems. They have a strong team led by Mance Harmon and Dr. Lehman Baird, who are two veteran technologists and with decades of entrepreneurial experience. And they have a strong corporate governance council, with members such as Boeing, IBM, Deutsche Telekom, and Tata Communications, which really puts them in a good position for enterprise adoption. They're also based right in our backyard in Dallas, Texas, so we've been able to form a strong relationship with their team, which it gives us some sort of peace of mind. Well, to wrap up, Lonestar Data Technologies provides leverages distributed ledger technology in order to create trusted data streams for autonomous devices and to create values for operators in industrial settings. To learn more, you can go to lonestardata.io or email me any questions, comments at info@lonestardata.io. That's it. Yeah.